Alright guys, so in this video what we're going to be talking about is dividing polynomials. So what that would look like is you have some kind of polynomial like, well, let's just look at this number 1 right here. Or maybe I'll do number 1 from the book. It just says something like x squared plus x minus 17. And the way it writes it is that polynomial divided by this polynomial. Okay, but the way, I mean, you guys would probably be more used to seeing something like that would look like this. All right, so we're dividing polynomials by polynomials now. And the book really goes over 2 different ways of doing that. One of them, in my opinion, is kind of useless. It's called synthetic division. It's not useless, it's very quick. It's very easy to do, but the problem is you can't really do it all the time. If you have your book with you, what synthetic division is used for, and you can see it, if you look at numbers 11 through 18 on page 229, what it shows you is pretty much something divided by, and here's all the examples straight down. You've got something divided by, here's the first example, it says x minus 4. Something, here's number 12, divided by x minus 2. Something divided by x plus 5, x plus 6. I'm just going to start making stuff up. X minus 1, x minus 8. And the list continues on, but the point is all of these look the same. They're all to the first degree. And that's all synthetic division can do. It only divides things to the first degree. And that's why I think it's kind of pointless, because actual polynomial division works every single time, when synthetic division really is only used for dividing things with first degree. And it is easy. So if you want to speed up the process, if you're dividing things to the first degree, then go ahead and use synthetic division. The book will show you how to do it. But I'm also interested in showing you how to do things like number 7, where it says x cubed plus x squared plus x plus 2. And then it says divided by x squared minus 1. That's something that synthetic division cannot do, that regular polynomial division can do. All right? When you have a second degree, or maybe you have a third degree, or you have some greater degree, synthetic division can only do it to the first degree. So my objective in this section is to really show you how to divide any kind of polynomial. It might not be the quick way, it might not be the synthetic division way, but it will be the way that always works. Synthetic division does not always work. So this worksheet's actually from Kuta Software. It's not going to be your homework. Your homework is going to be, I should not have closed the book. Your homework is going to be on page, it's 200 and something. Give me just a second. Here it is. Page 229. I want you to do numbers 5 through 22, all of them. 5 through 22, all of them. And I think I'm going to give you 2 days to do it if I'm not mistaken. So numbers 5 through 22, all. All right, now what I'm going to show you is polynomial division. And the easiest way to understand polynomial division is remember back to elementary school when you did regular division. And I just wrote out this problem real quick. Here's what regular division looked like. It was something like, if you had, well, let's even start before that. If it was written out like 10,443 divided by 9, the way they would show you how to do that is you would take 10,443 divided by 9 like that. And you'd ask yourself, okay, does 9 go into 1? No, it doesn't. So I can just kind of put a placeholder there, 0, but it doesn't really matter. Does 9 go into 10? Yes, it does. It goes in 1 time. 1 times 9 is 9. You subtract those. 10 minus 9 is 1. Bring down this, bring down this, bring down this. So you have 4, 4, 3. Start the process over again. Like that. And you just keep doing it. So you have, does 9 go into 14? Yeah, it does. 9 goes into 14 1 time. 1 times 9 is 9, subtract, 14 minus 9 is 5, bring down this, you have a 4 and a 3. Divide by 9 again. Does 9 go into 54? Yes, it does, 6 times. 6 times 9 is 54. Subtract, you end up getting a 0 here, bring down the 3. Now this is an interesting thing. You have a 0 there. You cannot forget about that 0. And I'm saying this because it's going to actually apply to polynomials also. But does 9 go into 0, 3? No, it doesn't. It doesn't go in at all. Put a 0 because it's a placeholder. 0 times 9 is 0. Subtract the 2. That's 0. Bring down the 3. Now the final question is, does 9 go into 3? No, it still doesn't go into 3. So you have a remainder of 3 over 9. Or you can simplify that to be 1/3. So if you type that into your calculator, though, does 9 go into 10,443 times? Yeah, it does. It goes in 1,160 times, and then a remainder of n 3/9. So really, if they put that as a decimal, in your calculator, it would look like this. 0.3 continued. 0.3333333. Okay. So that's the same concept that you're going to be applying to polynomials. The exact same concept. So polynomial division. Now, let's look back at this page. If well, let me focus on, there is what I want. This, we're going to focus on, find a good one to go from. Let's just do number 1. Number 1's good enough. All right, so if I focus on number 1, I'm going to first start off, it says this is divided by m minus 8. So I have m squared minus 7m minus 11 divided by m minus 8. So the question is the same thing. First you start off, well, there's another thing. You need to rearrange all these in descending order. What I mean by that is, real quick, here's just the tangent. If I have something like m to the 4th plus m squared minus 2 divided by m plus 1. The way I actually want to write this is like this. M to the 4th plus, I don't have any m cubes, plus m squared plus, I don't have any m to the 1st powers, minus 2. So every single thing has that place. And that's why I was emphasizing a second ago when you did 0, 3 divided by 9, you had to put a 0 there. That's why these 0 m's are important for the same purpose. And then m plus 1. And you divide it out like that. So now, here we go with this one. Question becomes, how many times does m go into m squared? All that matters is this and that. So how many times does m go into m squared? Or what do you need to multiply m by to get m squared? You could ask that question. Same question. All right? Well, you need to multiply m by m. So m times m is m squared. And that's what you're looking for. You want these things to add up. Because in a second, just like we did with the numbers, we're going to subtract them from each other. So m times m is m squared. So that's m times m. Don't forget m times negative 8 as well. All right? So m times m is m squared. M times negative 8 is negative 8m. Now what you're going to do is you're going to subtract these. And when you subtract that, that's going to be a negative m squared. This is going to be a minus negative 8m. So that actually ends up being a positive. So m squared minus m squared is 0m squared. There's nothing left over. Let me actually, instead of doing it like that, I'm just going to cross through them. They cancel each other out. It's negative 7m plus 8m is going to be a positive m. Okay? So these add up together to be positive m. Bring down the negative 11, just like with dividing numbers. Now the question becomes, what do I need to multiply m by to get m? And the answer is 1. 1 times m is m. Don't forget to also multiply the 1 by the negative 8. So 1 times negative 8 is negative 8. Subtract them. These cancel. M minus m is 0, nothing. Negative 11 minus a negative 8, so negative 11 plus 8 is negative 3. And that should be my remainder. There's nothing else that can go into negative 3, so I have a remainder of negative 3 over m minus 8. They might ask you to write it like that. They also could maybe ask you to write it like, so remainder negative 3 over m minus 8. They might ask you to write it as just minus 3 over m minus 8. I would say that's probably a more professional way of writing it. And And then I guess even lastly, one more way I could think about writing it would be like this. That'd be kind of weird. But all of those three ways that I just showed you are all the same way of writing it. Okay, let's work a few more examples. Let's look at the tougher ones maybe. Yeah, these are tough. All right, I'm going to do number 11. Then I'm going to do number 14, and then I'll be finished. So, number 11. Let's do that. Do number 11. Then I'm going to do number 14. Okay, and then I'll be finished. There we go. All right. Number 11. So again, when we write this down, we want to write x squared plus 0x minus 74. And we want, this is super important, we want a placeholder, okay? All right, and then it's being divided by x minus 8. So question becomes, what do I need to multiply x by to get x squared? So the first two terms are all that matters. X times x is x squared. And the whole reason that that's all that matters is because now we want to subtract these in a second so they cancel out. So there's x times x, now x times negative 8. Don't forget the negative 8. I don't know why, but last year tons of people were forgetting negative 8. So x minus negative 8, or x times negative 8 is going to be negative 8x. All right, subtract them. The whole reason we wanted x times x to be x squared is so that these would cancel. Now those are done. 0x minus a negative 8x, that's going to be plus 8x, is 8x. Bring down this negative 74. All right, question again. What do I need to multiply x by to get 8x? And remember, it's the first term, that's all that matters. You need to multiply by 8. 8 times x is 8x. And don't forget about the negative 8. 8 times negative 8 is negative 64. Subtract, like that. So 8x minus 8x is canceling out. Negative 74 minus a negative 64 is plus 64. So negative 74 plus 64 is negative 10. Excuse me. So that is the end of that. So you can write remainder negative 10 over x minus 8. You can write it like that. Maybe you want to write it like minus 10 over x minus 8. Either way, what it looks like to have a remainder is just a fraction on there. Okay, so that would be number 11. Now, the really long one. Yeah, this one looks a bit tougher. It's actually not too bad. The reason I say that is notice everything is already written in descending order. So we have p cubed minus 10p squared plus 20p plus 26, and it's all being divided by p minus 5. Now, if I didn't have 3, 2, 1, 0, I would need something there holding the place of whatever term. But I do, so I'm ready to go. Question becomes, what do I need to multiply p by to get p cubed? Answer, p squared. P squared times p is p cubed. P squared times negative 5, don't forget this part, is negative 5p squared. Subtract them. The reason you do that is so that those can cancel. Negative 5p squared is plus 5p squared. So you end up with negative 10p squared plus 5p squared is negative 5p squared. Bring down these. Plus 20p plus 26. Do it again. We're dividing by p minus 5. So I'll go ahead and rewrite that out here, but it's not essential to rewrite this every single time. How many times is p, or what does p need to be multiplied by to get negative 5p squared? So that's going to be negative 5p. Negative 5p times p is negative 5p squared, which is exactly what we wanted. We want that to be the same. Negative 5p times negative 5 is positive 25p. Make sure I did all that right. Looks good to me. So we are going to be subtracting them now so that these will cancel. 20p minus 25p is negative 5p. Bring that down. Last one. Divide it again by the same thing, p minus 5. Okay, p times what is negative 5p? Negative 5. Negative 5 times p is negative 5p, and negative 5 times negative 5 is positive 25. Subtract the whole thing. These cancel. 26 minus 25 is going to be 1. So I have a remainder, so I can write remainder of 1. I could write, if it's a positive 1, then I could also write plus 1 over p minus 5. So there's your remainder. So guys, I would really focus on this. Maybe in another video I'll show you synthetic division, but again, it's kind of pointless because you always have to divide by, you know what, I do need to show you another example. Hey, Miss Green Sage. Thank you. I do need to show you another example because I haven't divided by something squared yet. So I'm going to go ahead and do that now in my next example. Last example. Okay, so let's come back up here. No, it's not going to be on that page. Maybe this page. Wow, okay, Well, this is a pretty lame page of problems. There's stuff like 2p, you're dividing by 2p. Here, let me get the book real quick. You might have a better problem in the book. Okay. Yeah, here we go. All right, new page. So what the book says on number, oh yeah, it gets a lot tougher. Wow, that's ugly. I'm gonna do number 9. That looks like a really tough one. So let's do it. So we have 5x to the 4th minus 2x cubed minus 7x squared minus 39. All of that being divided by x squared plus 2x minus 4. Okay, so setting it up, x squared plus 2x minus 4, dividing this big long 5x to the 4th minus 2x cubed minus 7x squared. Notice there's a minus 39, but we're missing an x term, so plus 0x, and then minus 39. Wow, I might need some space on this one. Okay, here we go. Starting off, what do I need to multiply x squared by to get 5x to the 4th? That's going to be 5x squared. 5x squared times x squared is going to be 5x to the 4th. 5x squared times 2x is going to be 10x cubed. 5x squared times negative 4 is going to be negative 20x squared. Subtract these. So these cancel. I've got negative 2 minus 10, so that's going to be negative 12x cubed. And I've got negative 7 minus a negative 20, so that's going to be positive 13x squared. And I'm going to bring down the rest of my stuff now. So I've got plus 0x minus 39. Do it again. I'm dividing by this x squared. So x squared times what is going to get me negative 12x cubed? Starting to get pretty long. Okay, so it's going to be x negative 12x. Negative 12x times x squared is going to be negative 12x cubed. Negative 12x times 2x is going to be negative 24x squared. Negative 12x times negative 4 is positive 48x. This is a long one. All right, subtract. It's actually, we're almost done, believe it or not. It's not too bad. So these are going to cancel. Positive 13 minus a negative 24, so that's going to be plus 24, so that's 37. and then 0 minus positive 48, so that's negative 48x, and then lastly bring this down. Okay, gonna do it one last time. X squared times what is gonna be 37x squared? So that should be a simple 37. 37 times x squared is gonna be 37x squared. 37 times 2x is gonna be 74x. Wow. Plus 74x, and then 37 times negative 4 is going to be 148. Hopefully my brain doesn't fail me now. Okay, so subtracting that whole thing, let me actually write that in a different color. So those are going to cancel. Then you've got a negative 48 minus 74, so that's going to be, if I do this math wrong, guys, I think you get the point. 7, so 110, 122. So negative 122x. And then negative 39 plus 148. So it's minus a negative 148. So plus 148, that is going to be 109. Plus 109. Now here's a stopping point. Notice that I can't divide by an x squared. X squared does not go into x anymore. So I'm done at that point. My remainder is going to be negative 122x plus 109 divided by that whole thing over there. X squared plus 2x minus 4. You could write it like that. Again, I told you that you could also get rid of that. Make sure that, well, get rid of that, and you can probably just put a plus there if you wanted. That's the answer. That's a long answer. Okay. Anyway, if you guys have questions, what I would recommend searching in YouTube would be something like polynomial division or synthetic division explanations. Your homework, one more time, is to do, I think it was number 5 all the way through number 22. And if you guys have questions, well, I'll be back after winter break. So I'll see y'all later.